weathering, forming bicarbonate ion. And by this process, it will be reached finally water, forming calcium carbonate. So that, look here, we have silicate-rich rocks exposed to rainwater plus carbon dioxide from the air. It will produce carbon dioxide dissolved in rainwater, so carbon dioxide gas dissolved in water and becomes carbonic acid, H2CO3. Then reaction of carbonic acid with silicate minerals. Chemical reaction results in heat, breakdown of minerals, and release of calcium ion, which react with bicarbonate. For that, formation of calcium bicarbonate. When calcium ion with bicarbonate, it forms calcium bicarbonate, dissolves in flowing water. After that, transport of bicarbonate to river and sea. Water carries bicarbonate ion away from the atmosphere, lead to what? Reducing carbon dioxide concentration in the air. And portion of carbon dioxide is converted into dissolved compounds and removed from the atmosphere naturally. This is the impact of lithosphere on the atmosphere. This is the effect of lithosphere on the atmosphere. After that, look here. First, you have to know this reaction is an example of the role of lithosphere in achieving a kind of natural regulation of the Earth's composition. So, the process of weathering and the formation of bicarbonate salts acts as natural mechanism that help reduce the concentration of carbon dioxide in the atmosphere and limit the greenhouse effect over the long term. So, as you see here, rocks affect the properties of water through the dissolution of some minerals. When the rocks here decomposed, makes weathering happens to it, so some minerals come to water and change the properties of water. When water passes through different layers of rocks, the concentration of salts and dissolved elements such as calcium, magnesium, and iron salts changes according to process explained by the law of solubility in chemistry. For that, the laws of solubility explain why water properties differ from one region to another, and why certain area produce hard water rich in calcium and magnesium. Use passage over specific rock type, and they also explain lithosphere role in supplying hydrosphere with salts and elements. So, the amount of substance that dissolves in water depend on several factors, the most important of which are water hardness. Water hardness. Hardness is a property of water resulting from high concentration of positively charged ion, specifically dissolved with calcium and magnesium. Specifically dissolved with calcium and magnesium ion or water causes numerous problems, such as reducing the effectiveness of soap and forming lime scale deposits, scales in boilers and water pipes. So please don't forget, hardness of water comes from increasing the concentration of calcium and magnesium ion. It is very difficult to use soap with water and the soap doesn't make bubble due to the hardness of water, due to increasing in the concentration of calcium and magnesium. So also it affects inside the water pipes, inside the boiler. So we have to clean it very well. After that, look here, soft, moderately soft, slightly hard, moderately hard, hard, very hard, over 300. Nature of chemical bonds in minerals. Minerals with ionic bond, such as calcium carbonate, found in limestone, break down easily in water, especially in the water contains carbon dioxide, which converts it into an acidic solution. In contrast, mineral with covalent bond, such as silica, in quarters dissolve very slowly. For this reason, silicate rocks remain more resistant to weathering. So, if you have calcium carbonate, the type of bond inside calcium carbonate is ionic. But if you have silica in quarters, the type of bond inside here is covalent bond, and the covalent bond is very hard to be decomposed. So silica will be more resistant for that weathering than calcium carbonate. So silica more resistant, more harder to weathering. So that's for the temperature, the effect of temperature. The solubility of most salts and minerals increases with rising temperature. Solubility of most salts and minerals increases with rising temperature. Thus, hot spring water, for example, can dissolve more minerals than cold water. If you know, in a certain place, the spring here is not hot. But if you have another place, the spring inside this place is cold. It's hot, cold. One of them is hot spring water, and the other cold spring. Which one of them contains more minerals? The hot spring or the cold spring? Here you have to know that temperature plays an important role in increasing the ratio of dissolved minerals. So hot spring contains a lot of minerals. If it is compared to the cold spring,